Hello, good evening. My name is Yogendra Kumar. I'm a maths teacher at askIITians. Okay, today we are going to do a lecture number 2 on squares and square roots, right? Okay, so we already discussed about the weights of this chapter in your exam. Okay, it comes for 11 marks, so it is really important chapter. And not only for these marks, okay, we need to remember this chapter and concepts of this chapter for our upcoming chapters also, right? Okay, we will be using these all concepts in our daily life also, and then coming chapters which you will be having in your further grades, right? You need to apply these knowledge, right? There are many Olympiad exams which are framed around questions are framed from this chapter, and using properties of square roots and all, which we are going to discuss today, right? So let's get started. This chapter is a really important chapter. Okay, so pay attention to what I'm going to explain to you, right? Okay, let's get started, guys. Okay, so what are we going to discuss today? Finding squares by different methods, right? And properties of squares of the numbers, right? Properties of squares of properties of squares of a number, right? We need to understand these properties of squares of numbers. Okay, then Pythagorean triplet, which is also related to our squares only, right? So we have seen already how do we find out this square, right? We have seen what we know. We have seen in the first lecture that how to find out square of a number. So we can multiply the number by itself, then we get the square of this number. Like suppose I want to find out 5 square, so 5 into 5 is what? 5 square, which is what? 25. So 25 is the square of 25 is the square of 5, right? We are getting this. Now what is the another method? We can use this identity. Now how come this identity is coming, right? You might be having this doubt. Okay, that a plus b whole square is what? A plus b into a plus b, right? So you can just remember that a will be multiplied to this a and b also will be multiplied to a and b here. So what are we getting? A square plus ab plus ba plus b square, which is nothing but a square plus 2ab, because ab and ba are same, so that's why it is what? B square. Suppose you have a minus here, so what? Only the middle term will come minus. By doing same way you can understand. So what we'll get? A minus b whole square we will get as a square minus 2ab plus b square. So remember this also, right? I can do this proof later on also, right? But I think you can understand this here only, right? So this is what we are going to learn now. Right? So we can do square by two methods, okay, which is nothing but again we are splitting the number into two parts and then we are doing this square, right? This example you can see 57 square they're doing. So how they're doing? 57 is breakdown as okay, 57 square is written as, see here, a and b, okay, like this it is breakdown, okay, like this here. Okay, it should be ideally like 50 plus 7, right? 50 plus 7, so 5 square we can see, so 25, right? Like that we can see here 50 square will be what? 2500, right? Like that we can see. We can learn this. Okay, let me explain you with the example, okay, like this here, right? So what we do here, 89 can be written as 80 plus 9 whole square. So what we can do? Now we know the property a plus b whole square is what? A square plus 2ab plus b square. This is the identity which is valid for any numbers, okay? Any whatever numbers you have, you can apply this identity, right? So what we have, 80 square plus 2 times of 80 into 9, right? We multiply both the numbers plus 9 square. So what are we getting? 8 square, right? What is 8 square we have? For bigger numbers we can use this property, right? Okay, so let me write down here. What is 8 square we are getting here? We are getting 64 square, right? 8 square is 64 and 0, so 2 zeros, you can multiply 80 into 80. Okay, you can do that way. Now here 9 twos are 9, 9 eights are, you can understand this is what here 72, and 72 times 2 we need to do, so it is 144 and 10 here plus 81. Now we are going to add this all, right? 6400 1440 and then 81. So what are we getting? 1, then here 2, then here 9, and here 7. So we are getting answer as 7921. This is what our answer, right? I hope you got the idea, right? Same way, the previous question 57 also we can do the square like this only. 50 plus 7 whole square. So what we can do? 50 square plus 2 times of 50 into 7 plus 7 square, right? So what are we getting? 2500 plus what here? 700 plus 49. So what we can say? 49 here, and now we can add it. So 2 here and 3 to 49, right? That is what we are getting the answer. You can understand this also, but I think this is also pretty easy, right? You can understand this way. It is comparatively easy. We break down the numbers into two part and then we keep on adding like this. Okay, we can do like this. So this is what using our property. Okay, you can understand this method also. 8 and 9 are the numbers. So 8 square 64, right? 8 square is what? 64. Then the product here, this is what? 152, right? 152 and 81 here. So we keep here 1 2 here as it is, and this 79 we will put here, right? You can understand this way also, but I think what I am explaining, that is much easier than this, right? I hope you got it right. So this is what, this is the method we can use here. Like suppose I need to do 105 square, I need to find out this. Now 105 square, we can do 105 into 105, right? What is the first method we have? Like this, okay, 105, 105, we can do like this, 5 here, 5 fives are, and then 2 here, and then 5 here. Now 0 0 0 here. Now sorry, my bad. Okay, this will be here 5, then 0 here 1. So what are we getting finally? 5 2 0 1, and here 1 1 1 0 2 5, right? So what we can do, let me break down. Okay, 100 plus 5 whole square. So what we can do here? 100 square plus 2 into 100 into 5 plus 5 square. So what are we getting? 100 square is what? You need to just double the zeros here, right? So this is what we got. Now here 10, 5 into 2 is what? 10, 10 into this will be what? 1000 plus 25, right? So we can add this all, right? We can add this all, and are we not going to get the same answer? 11025. This is what the answer we got, right? I hope you are finding it easy. So let's stick to this method, right? I think that is what previous method is also fine. What we do here, we don't write 80, we just write 8 here, right? So that is also okay. There is no problem, right? Here 80 we can write down 80 in place of 80. We are just using 8 here. Now why we are adding, I hope you are getting the developing the idea why we are adding 79, why we are keeping 70 as it is here, because 80 will give you two zeros, right? 80 will give you two zeros. So that's why we are keeping the unit places from here, one unit place of this here, unit place of this here, and then whatever number is there, that as it is, right? So this is what we are developing, the shortcut kind of thing here, right? I hope you are getting it. Okay, you can apply the same method here also. Okay, in this question you can do that way also here, right? But I believe that is, this is also fine, right? This way you can do for like this 1000, 1000 plus 50 whole square. I need to find out this square, right? I need to find out this square. So what we can do, this one. Now 1000, how many zeros will be there? Double the zeros, so one more zero will be there. So okay, let me write down the first, okay, this square. Then what? 2 into 1000 into 50 plus 550 square. So we got 10000, 6 zeros, plus now here how much? Okay, 100 here, and so it will be how many zeros? 5 zeros, right? Now here 2500. So we can add it all now. 2 zeros will be there. Now 25. Okay, 002510 will come, and then one more zero. That's all. This is what our answer, final answer. I hope you are getting it right. We can apply the whole square method like this. Now, what is the next point, which is very, very important? Okay, we need to learn the properties of squares of the numbers, right? So let's see. Squares of number can only end with 0, 1, 4, 5, 6, and 9. Okay, how does it come? Okay, how they are saying like that? Okay, let's see. Now, 0 square is what? 0. 1 square, I'm writing just squares, okay, here few squares, and then we will observe. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is what? 16, 5 square is what? 25, 6 square is what? 36. Let me do more here. 7 square is what? 49. 8 square is what? 64. 9 square is what? 81. 10 square is what? 100. 11 square is what? 121. 12 square is what? 144. 13 square, 169. 14 square. 14 square will be what? 196, I think, right? Yeah, 196. Okay, we can see more. 15 square is what? 225. 16 square is what? 16 square will be 256, right? I hope you are getting it. Try to remember as many as possible, because it is going to help you in calculation, right? As much as possible you try to remember. Okay, 17 square will be what? 289. 18 square will be what? 324. 19 square will be what? 361. 20 square will be what? 400. 21 square will be what? 441. 22 square will be what, guys? 484, right? Okay, 23 square. Few more, that's all. We are done. 23 square will be what? 529. 24 square will be what? 576, I believe, right? We can cross verify easily, right? If any confusion is there. 25 square is what? 625. Now 26 is not needed. Okay, let's come to the directly. 30 square will be what? 900. 35 square will be what? 12. 25. Now 40 square will be what? 1600. 45 square will be what? Okay, now 50 square will be what? 2500, right? Can you see here, guys? Okay, what is the main thing I wanted to you to observe? Unit place is 0 or 1 or 4 or 9 or 6, 5, 6, 9, 4, 1, 0. Observe the unit places. Okay, observe the unit place here, unit place of squares. I've written, I think, more than enough, right? Many unit places I've shown, many squares I've shown. So unit place is what? Can you observe here? Is there anywhere unit place digit is 2 or 3? Is there any unit place digit is 2 or 3? No. Or 7? No. Are you getting me? 2, 3, 7, 8. 8 is not there, right? So that is what. Can we remember this property like this also, that if a number is ending with or number's unit place digit is 2, can it be a square root? Can it be a perfect square? No, it will not be a perfect square, right? So this is how you can remember this property, right? You can remember this way, that square of a number, when we do, so unit place digit is going to be either 0, 1, 4, 5, 6, or 9. That's all. These could be there, right? Digits could be 0, 1, 4, 5, 6, or 9. That's all. You cannot have 2, 3, what else is there? 7 and 8. These are not there. Unit place, never. Or can we remember this property like this also? If we have unit place digits as 2, 3, 7, or 8, then the number will not be a perfect square, right? So this is what very, very important point of discussion here. You need to remember this, right? So let's move on to next property. If the number of zeros at the end is even, then the number is a perfect square. Otherwise, we can say that number ending at in the odd number of zeros never perfect square. Okay, what is the meaning of saying here? Like 2500, it is what, 50 square? But 500, right? 500 is not perfect square, right? Even number of zeros are there. So just you need to make one correction here in this line. Okay, obviously this should be the perfect square, right? Okay, this one here. They mean to say that 100, what is 10 square? 10,000 is what, 100 square? Okay, this is not perfect square. Not by using property. Okay, we can say not a perfect square. I hope you got it right. This is what the main idea, right? Okay, this is what we are trying to say by using this property. I hope you got it. Now let's see further. If an even number are squared, it always gives even number. Also, if odd number is squared, it always gives odd numbers. Okay, you can observe this here also. Odd number is squared, so odd number we got. Odd number is squared, odd number we got. Odd number is squared, odd number we got. Odd number is squared, odd number. Even number is squared, even number we get. You can remember this property, by the way, this way also. Suppose 2n. Even number is what? Even number is of this format. So what it will give me? 4n square, which will be what? 2 times of 2n square, which is what? Even. Right? Now odd number. Odd number will be what? 2n plus 1 format. When you do the square of that, what do we get? 4n square plus 2 into 2n plus 1. So what are we getting? 2 times 2n square plus 2n plus 1. So are we getting the odd format only or not? Odd number. I hope you got it. It is again odd number it is generating, or you can write down, right? This property is what you can remember like this, right? Okay, let's go to the next property. If the natural numbers other than 1 is squared, it should be either a multiple of 4 or exceed the multiple of 4 by 1. Okay, let's see here this property. Okay, 1, it is not multiple of 4. Other than 1 they are saying. So 4, it is multiple of 4. It is exceeding multiple of 4 by 1. It is exceeding multiple of 4 by 1. Sorry, it is multiple of 4. This is exceeding multiple of 4 by 1. This is exceeding multiple of 4 by 1. Sorry, this is multiple of 4. Okay, by the way, can we understand this property here only? Right, that's why we did this one here. Can you see this further here? Can I take 2 more common here? So 4 n square plus n plus 1. So it will exceed by 1 by the multiple of 4, right? Can you observe this? Or it will be multiple of 4, which is what, like this here, 4 times of n square. So you can understand from here also. I hope it is pretty much clear, right? That's all. So it happens to every square of a number, right? Okay, let's see this. It is noted that unit digit of a square is a natural number equal to the unit digit of the square of the digit at the unit place. Okay, it is a long sentence. I know you might be confused here. Okay, let me take some example like 21 square is what? 441. What is the unit place digit here? 1 square. Unit place digit is what? 1. So what is the unit place digit here? 1, right? Which is what? 1 only. Now, 22 square, which is what? 484. Now, what is the unit place here? 2 square, which is what? 4. And this is what? Same thing right here. Now, 23 square, which is what? 529. Now, what is unit place digit? 3, which is what? 9. And that is what? Same here. That is what this property is saying, right? I hope you understand this. Can we move on to next property, guys? Okay, now this property, for every natural number, we can write it as next number to n. Some number is there n, and next number ka square. That is this only. So by the way, this is what? Okay, if you remember this property, this identity a plus b and a minus b, right? This identity you can remember. This is what actually it is applied here. So this is what our a, this is what b. So we can write down here what? N plus 1, right? Okay, 1 minute. I need to make this correction here. So n plus 1 plus n, and then n plus 1 minus n, right? So n get cancelled. Are we left with this only or not? Tell me, right? So this is how this property is given. So any number, suppose it is there 4 square minus 3 square, next number, right? So what it will be? Just do the sum of them, right? What we will write here? 7 means 4 plus this. Okay, suppose I have 51 square and minus 50 square. So what we'll do? 51 plus 50, which is what? 101 is the answer. Are you getting it? So sometime this property will be helpful like this, right? We can use this property like this way. I hope you are understanding this. So let's move on to next property. If a number is squared, it equals to the sum of the first n natural numbers. Okay, what is this now? Okay, let's see. So 1 plus, okay, odd natural numbers, right? Can I add two odd natural numbers? Okay, so what we got? 2 square, 2 natural numbers are added, right? So what we are getting? 4, right? Can you see this? Now suppose 1 plus 3 plus 5. I think this property we did last class also. So remember, 3 numbers are added, so 3 square, which is what? 9, right? Now 1 plus 3 plus 5 plus 7, what it will be? 4 square. You can see it will be what? 16, right? You can see this. Okay, now 1 plus 3 plus 5 plus 7 plus 9, what will be? 25. So what I said last class also, 5 plus 7 plus n. Suppose till n we are adding, so this is nothing but n square only. So this is what the property it says, right? I hope you got it. You can try for more numbers and you can observe, right? We have seen this property this way also, right? Okay, that this is there. Now like this. I hope you are getting, right? Okay, number of blocks. Okay, how many number of blocks are there? We can keep on adding like this. Okay, one and it will be always square. Okay, for any natural number says n which is greater than 1, we can say, okay, now what is this? Okay, let me just make the correction. These squares, I think you can't see properly. Okay, just one correction here. Give me just 1 minute, guys. Okay, I'm just making here correction here. Okay, what do we say here? Yes, this one. Yeah, now I think you can look at it in proper form. Yeah, so this is what it is. Okay, what it is saying now, let me show you again in the bigger. Okay, yeah, right. What we say, any natural number. Okay, suppose there is a natural number. Let's say, okay, first natural number. Okay, like first natural, we start with 1, but we are taking greater than 1. So let's say 2 only I'm taking, right? 2. So now n is equals to 2. So what are we getting? 2n, which is what? 4, right? Then 2 square minus 1 and 2 square plus 1. Okay. Okay, let me write down here again. Give me 1 minute, guys. Okay, I'm so sorry. Okay, I know I'm correcting it. Okay, here 2 times of 2, right? 2n. So what are we getting here? 4, here 3, and here 5. Are not they Pythagorean triplet, right? Square of this will give you square of these ka sum, right? 5 square is same as 3 square plus 4 square. We verified. Now let's say n is equals to 3, right? 3 I'm taking. So 2 into 3, and then 3 square minus 1 and 3 square plus 1. So what are we getting? 6. Now here, tell me, 3, 8 here, and then here 10. Are not they Pythagorean triplet? So they are Pythagorean triplet, right? We verified. Pythagorean triplet, do you understand? If I take this side, this is 3, this is 4, this is 5, right? They satisfy this. Pythagoras hypotenuse square is what? Opposite side. Okay. Opposite side O and base side. So h square is equals to O square plus B square, right? This is what we say. Hypotenuse is the sum of other two sides ka square, right? So that is what we are saying here. This right angle triangle is going to be like this. Okay, 6 here, 8 here, and now 10 here, right? So this is what Pythagorean triplet. Same way we can do for any numbers. Okay, like n equals to 4, what we will get? 8, then what here? 15, then what here? 17. Are you getting it? So this way we can remember it. Okay, 17 square is what? 17 square should be what? 8 square plus 15 square. Now this is what? 17 square is 289, and this is what? 64 plus 225. So you can see addition of these two is what? This one, right? So this is what Pythagorean triplet again. So that is what they property. Okay, now we are going to discuss this only. These all are a Pythagorean triplet. I hope this is easy to understand now. Pythagorean triplet is what? So this word will be used again and again. Okay, so you should remember. I already explained you, right, what is Pythagorean triplet. Okay, so some of the you need to remember. Okay, let me write in detail here. This is what hypotenuse. My bad. Okay, this is what our hypotenuse. This is what altitude, and this is what base. So hypotenuse square is what? Altitude square plus base square, right? This is what you need to remember, right? That is what we need to remember, right? This is what you're going to remember here. So this is what our Pythagorean triplet. So these triplets will be what? Okay, hypotenuse square will be. So you can see all these in these all examples. Okay, we have that relation, right? Can we move on to this? Okay, check if these are Pythagorean triplets. We already checked, right? What I said, biggest number should be what? Smaller numbers ka square. So what are we getting? 225 here plus 49 here. So what are we getting? Okay. Okay, we didn't check. Okay, I'm so sorry. I was having 8 here. That was correct. But here it is not coming true. What is it coming? Okay, guys, this is wrong, no? This is not correct triplet, right? What we are getting here. So 289 we get here, and now here what we are getting 4, then here 6, 7, and then 2, which is not equal. So they are not Pythagorean triplet, right? We can say that they're not Pythagorean triplet because it is not coming equal. Detailed solution is given here, right? I hope you got it. Find the square of the following number. Okay, this number ka square we need to find out. So what I said, okay, you can remember it like I would say 90 plus 9 ka square we can do, right? You can write here 81. Okay, let me write first 90 square plus 2 times 90 into 9 plus 9 square, which is what? 8100 plus what we get here? 162 0, right? 162, 81, 9 nines are 81, 81 times double is what? 162, and 10 is there, plus 81. So what are we getting? 1 here, then 8 here. I'm so sorry. Okay, it should be 0 here. Yeah, addition we need to do. Right, so what are we getting here? 0. Then what do we get here? Unit places, okay, tens places added. Okay, now here it's 6 and this is 1. So 7 and 8. 8 we'll get here. And then here 9, right? This is what we're getting. 9801. Now you could have done this way also. 99 is what? 100 minus 1 square. So what is 100 square? 100 square is we can write down like this: minus 2 into 100 plus 1 square, which is what? 10,000 minus 200 plus 1. So what are we getting? We can subtract easily, right? 9801 we will get. So we can do this way also. Okay, check whether these are Pythagorean triplet. We have already checked. You can change the question here. 8. Yes, they are Pythagorean triplet. 17 square is what? 8 square plus 15 square, which is what? 289, 64, and 225. And this is also 289. So this is what? Correct Pythagorean triplet. We can change, right? Not triplet, right? Okay, that is the answer given. We already did. So I changed the questions or triplets. Okay, fine. I hope you have understood. Okay, this is what the discussion. Okay, you can watch it. You need to remember those all properties. Practice questions. Okay, so that you can remember those all, right? So we by this, okay, we complete our second lecture on squares and square roots. Okay, let's continue to the next lecture in the next session. Okay, thank you very much. Bye bye.